The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone. Welcome to Seven Signals Best Practices webinar series. We're going to get started here in just a few minutes. I've got 2:53 local time. I promise I'll kick this off at 3 o'clock on the nose and we'll get going. Thanks for joining us early today. I'd love to hear from the folks who are joining in early to see where they're from. So please use the Q&A pane to tell me where you're from. I do see some recognizable names on there, folks we've talked to in the past, so I know there's at least I want to say that there's someone from Russia on today. I know that there is someone from the UK on. So help me out with the rest of you folks, if you don't mind. Let me know where you're calling in from. And if you're not familiar with how to use the GoToWebinar control panel, there is a drop down in the question and answer pane. So you can go ahead and just message it to me, so you don't have to worry about letting the world know where you're calling in from. Oh, Texas. Welcome. So is Texas, Jim, is Texas West Coast time? So this is lunchtime for you, sir.
Yeah, Central Time for most of Texas, I think.
Well, thanks for Central Time. Okay, got it. So maybe you just had lunch then. All right. Welcome. Thanks for joining us. From Penn Ed. Welcome, Ed. Thanks for joining. And I'm up in Cleveland today, as is Mr. Vajda. Jim's normally down in Cincinnati doing these broadcasts, but he's up at headquarters today, so we're lucky to have him up here today. He's got a 4-hour drive back, Jim?
In the afternoon with traffic, it'll be 4.5 hours. That's probably what I'm planning on.
All right. Well, hope you got some
always good to
podcasts.
Visit the HQ and stay connected. Oh yeah, I got the podcasts queued up. I've got WLAN Pros. I've got Clear to Send. I've got
Packet Pushers too.
I really prefer the Wi-Fi specific podcast.
Oh, okay.
So the other one is the Contention Window. That one's a little bit newer.
Oh, I'll have to write that one down. I don't have that one.
Yeah. Good one.
What do you have outside of Wi-Fi?
The boring stuff. This American Life.
That's a good one. From
Radio Lab. Econ Talk. The Journal from the Wall Street Journal. That one's pretty good.
If you like This American Life, you might want to check out American History Tellers too.
Okay.
That's a Wondery podcast. It's really good. I know. I'm sorry. I know we've got some non-U.S. folks on here too. World history is awesome as well. I just haven't found a good podcast.
Dan Carlin's Hardcore History, very excellent podcast, but it really takes some investment. You'll do like these 18 episode, 3-hour podcasts about the Mongol Empire that are just epic, but it takes a lot of investment to listen to the whole thing.
Well, that's for your 70 to 150 mile bike rides, right?
Yes.
On the weekends.
Oh yeah. That is perfect for that.
All right, folks, I've got about 3 minutes left before 3 o'clock. I had a couple of folks message me about where they're dialing in from. So we got Texas, Pennsylvania. I know some international folks are on. If you haven't let me know yet and you feel like messaging me, I do see some familiar names. I do get offended when you don't message me on the board and tell me where you're calling in from. It gives me a complex, Let's see.
Don's very sensitive, guys. Let's make sure his needs are met here.
Just ask my wife. So we'll give folks another 2 minutes to jump on. We've got a big registered audience today, so I'm expecting a nice crowd today, which is fun. Get some interaction going. I got thank you, Boston, Mass. All right. Welcome aboard from Halil. Everyone else is shy today. That's all right. We'll do all the talking. But for those of you who do have questions throughout the webinar, please feel free to ask your questions throughout. If it's relevant to the slide and I catch it in time, I will, ask Jim the question in real time. Others I'll let go till the end. But I will try and make it as interactive as I can and keep my eye on the chat board as we go. And I know we do always get questions about a copy of the slides and a copy of the recording. We're definitely happy to share those as well. Give folks another minute here and then we'll get going. All right, Jim, I've got 3 o'clock. Why don't we get going?
Sounds good.
All right. Well, thanks again, everybody, for joining us today. Good afternoon, good morning, good evening, depending on where you are in the world. That will make sense to you. Today, you joined us for Wi-Fi 101, Basic Elements and Troubleshooting. With me today is Jim Vajda. Jim is our resident CWNE. Jim, tell us a little bit about yourself, if you don't mind.
Yeah, thanks, Don, and thanks everybody for attending today and tonight, or whatever time it is, to all our international attendees. Appreciate you guys being here. So I'm the Director of Global Wi-Fi Solutions here at 7Signal. I do a lot of SE work, and I manage our team of SEs. I'm a CWNE and also a CCNP wireless. My most recent experience before joining 7Signal was in healthcare, but I've also got a lot of Wi-Fi engineering experience in other verticals too. You can follow me on Twitter at Jim Vajda, or my blog, which is 100% Wi-Fi content, unlike Twitter, is framebyframewifi.net. So you can follow me there. And also, recently I was on the WLAN Pros podcast talking about troubleshooting and some of our tools here at 7Signal, so check that out. Don, we were on the week of webinars series with CWNP. Yes. And we will be at Wi-Fi Trek next week as well.
We will indeed.
There you go.
All right, thanks, Jim. Let's get this thing going. Before we get into some of the content, I do have just a few minutes of slides to run through about 7Signal for those of you who are not familiar with us. We were founded in 2007 in Helsinki, Finland, and moved to the U.S. In 2012. We had a major milestone last quarter in that 1 billion number that you see there. So now our solution analyzes over 1 billion daily data points from all the interactions of the Wi-Fi networks and devices throughout our customers. So we're really excited about that number. I'm really excited about the success that our customers are having. We do have over 200 of those, over 30 partners around the world. I know I see some familiar names, so I know there's some partners on the line as well. So with that comes things like GDPR. So we are GDPR compliant. For those of you who have organizations in the EU and follow that compliance, we are ready to support our customers' needs as it relates to that. We've got over 12 patents as well, global patents. So the things that you see from 7Signal, you're not going to see from anyone else. So that does make us unique. And we do complement your access points. So the things that you see from a data perspective, you aren't going to see inside those access points as well. We're certified in over 40 countries, so we've been homogenized from a product standpoint. That's for our sensors. So regardless of where you are, if you're in one of those other countries around the world that we're not certified in, we will work with the proper governing bodies to make sure that we are, so you can utilize our product no matter where you are. And we've got 10 of the Fortune 500, a lot of growth possibility there. So in a nutshell, our customers come to us to find and fix Wi-Fi issues. And we've, since that 2007 timeframe, we've created an outside-in enterprise framework. So we become part of the network. We're not spot fix. We're a strategic partner of yours. And everything that we do is AP and device agnostic. So the problems that we find on Cisco or Aruba or Mist or any other access point or any of the big three wireless device manufacturers, operating systems, we'll be able to diagnose and find those issues with ease. We are modular, so we don't sell you software you don't need. So depending on your specific challenges within your organization, they may be device related, they may be infrastructure related. We'll dig into just what's going on through the discovery process to make sure you have a solution that you need. All of our solutions are cloud-based and access our reports, alerts, and analytics in the cloud, so the data is served up there. And what we're looking for are what the industry believes and we believe are the top 7 Wi-Fi problems. So no matter what the issue is, everything boils down to these 7 things that our devices and our software, sensors, are looking for. So that's congestion, coverage, and interference, network services problems, roaming issues, drivers and adapter combination issues, wireless LAN configuration issues. And what we're doing is we're running active and passive tests in the background, looking for things like packet loss, latency and jitter, delivering you a MOS score, really looking inside that device and using a full spectrum analysis in the case of our Sapphire Eye. This space is what we refer to as wireless network monitoring, and that's the space we play in. So the legacy space, we can't talk about our outside-in approach and not talk about what's going on now. And a lot of our folks on the call today are experiencing this. And basically, you're relying on the access point provider, your network provider, to give you diagnostics on the system, but you've got no visibility into the end user experience, among other things. So 7Signal lives on the outside. As I said, we're on the outside in, so we've got visibility into your devices and into the air with our sensors and giving you that full visibility of the network that you just can't get from anybody else. So you're getting to that root cause fast and easy. There's no more, hey, this happened to me a week ago. I couldn't get online. You can go back in time and see just what's going on with the network at that given time on a specific device. So there's so much that goes into what we do with our products and services. So it gives you that actionable information to get to the root cause of issues so you can fix those problems. So we've got 2 main modules at 7Signal. That's Mobileye on the left, Sapphire Eye on the right. Mobileye is the application that runs in the background on devices, and it finds 5 of the 7 problems, if you will. So the difference between a Mobileye and Sapphire Eye, Mobileye is really that solution for finding device issues, right? The roaming problems, adapter and driver combination issues. Whereas Sapphire Eye is the client that's installed in the ceiling, and we will be coming out with a new desktop sensor as well that's untethered, that's not connected to an Ethernet port. It's something to look forward to for those prospects on the line that have specific needs in the retail space especially. But that is our hardware and software subscription sensor, and really with that you're able to find radio frequency, co-channel interference issues, network issues, that kind of stuff. So really powerful tools that our wireless engineers really enjoy, and network engineers, network generalists. You don't need to be a CWNE like Jim Vajda to use our software. Then my last slide here before I hand the controls over. As Jim mentioned, we will be in Nashville next week at Wi-Fi Trek for our regional user group. We're also a sponsor of the event as well. Really excited about it. Looking forward to meeting a lot of you on the line today. We'll also be in Prague October 7th, so circle your calendars for that as well, especially for those of you who are dialing in from international places. Wireless LAN Pros will be there for their conference. We will be there, and we'll also have a regional group there as well. And if you'd like to register, all you need to do is go to go.7signal.com/RUG, and it's completely free. We'll buy you lunch, tell you about our products and services and how our other customers are using it, do some brainstorming. And they're really enjoyable. This will be our 6th one just this year. So very exciting stuff. And with that, Mr. Vaughn, I'm going to hand the controls over to you. Let's get into the meat and potatoes of this.
Awesome. Thanks, Don, and great intro there. So Wi-Fi 101, we're going to cover some of the foundational fundamentals of Wi-Fi today and make them easy to understand, especially for people that are seeing these, getting these concepts for the first time, and make this relatable and make it fun, and kind of take the magic out of it, right? Because for a lot of people, especially end users, Wi-Fi is kind of this mystery. It's magical. It's how are we transferring data back and forth wirelessly, and I can't see it. I don't know what it does. I know the light on my AP is on and my laptop or phone says it's connected, and that's all I know, right? So for a lot of folks, it's mysterious, and it really doesn't have to be. There's some fundamental concepts that we'll explain that'll help it make a lot of sense to you. So let's talk about troubleshooting, and in the legacy or traditional environment, it kind of goes like this. Your end users have a problem. They're convinced it's a Wi-Fi problem, and maybe it is, or maybe it's not. But they call the help desk, they call you, they're waiting for you at your desk in the morning before you've had coffee, and it's, can get kind of ugly, right? But they don't have a lot of good information. It disconnects, I can't connect, it's slow, right? The Wi-Fi stinks, all right? And that's the rated G version. It can get much worse. But that's not very helpful. Really, if you look at the entire system involved in delivering applications, Wi-Fi is one component. It's got a myriad of subcomponents, and there are all sorts of other places where that application performance could suffer. And so just relying on what you get from grumpy users makes troubleshooting problems difficult. And so when we're talking about Wi-Fi problems, there really are 4 areas that you should focus on during your troubleshooting. And our tools make this easy. So the client devices, the air, the RF, where that wireless transmission is going, the access points, I'll call them APs from here on out, and then the network, the route switch network, the internet connection, all those things. And there are all these root causes within these buckets where we can find the cause of issues. The adapters and drivers on the client devices themselves can sometimes result in Wi-Fi problems. And for a lot of end users, they never even consider that the problem actually could have its root on the device they're using. For them, the Wi-Fi access points, the APs, are where bad Wi-Fi comes from. It couldn't be the actual performance of their own devices. In the air, in the RF, there could be interference from other Wi-Fi networks, or even sources of non-Wi-Fi interference. We'll talk a lot about that. And the APs, their configuration, there may be oversubscribed and there may be congestion. There could be coverage problems. Those are easy to understand. Or maybe the AP is misbehaving and the radio is stuck. And then up on the network, maybe DHCP is not working. You can't get an IP address. An internet connection went down, and that looks like a Wi-Fi problem, even though it's just an internet connection problem. Authentication services are unavailable. All those things are going to need investigation. And when users say, oh, the Wi-Fi stinks, it doesn't really, point you in any specific direction to find the root cause of that problem and get it fixed. So that's where our tools come in and helping you really focus on where you need to troubleshoot. So the spectrum, the RF spectrum that Wi-Fi uses is part of a big, broader swath of spectrum that in the US is managed by the FCC. In other countries, there are other regulatory bodies that manage the spectrum and decide who gets to use it for what. A lot of spectrum is licensed. That means the regulatory body will license that spectrum to, say, a cellular carrier. Cellular carrier pays the government a lot of money for exclusive access to that spectrum, and no one else can use it. So you'll see that in, say, the 700 megahertz band and the 800 megahertz band. There's a lot of LTE going on there. But other parts of the spectrum are unlicensed. And this is where regulatory bodies decided that, why don't we just have some spectrum that people can just do whatever they want in? And that'll spur innovation, because you don't need to come and buy a license from us. You don't need to go get a ham radio license. You don't need anything. You just have to make sure that the devices you use meet these requirements, and you're all set. You can use these so-called unlicensed bands. In the US, the unlicensed bands that we're concerned with are the 2.4 gigahertz and 5 gigahertz band. There's also the 900 megahertz band, which is used for IoT and other applications. But for Wi-Fi, it operates on the 2.4 gigahertz band and 5 gigahertz band because those are unlicensed, and you don't need any approval to transmit on those frequencies. So one of the major differences between the 2.4 and 5 gigahertz band is the propagation, and that's how far the signal will go from a transmitter on one of those frequency bands. So the 2.4 gigahertz band has a much longer wavelength, and that means it goes further before its signal degrades, which could be a benefit if you're just talking about coverage, or it could be a problem if you're talking about interference. The 5 gigahertz band has a smaller wavelength, so it attenuates faster and drops off faster, and so it doesn't cover the same area that you could with 2.4 gigahertz. It also means it's less likely to interfere with neighboring access points using the same channel. And we'll talk a lot about interference and co-channel interference as we go. So RF attenuation, right? This is the phenomenon that you experience when you drive under a bridge or through a tunnel and you're listening to the radio. Don's got his soft rock blasting, and he's coming down the highway, and all of a sudden,
smooth jazz, buddy.
Smooth. Oh yeah, okay. His Kenny G
right. Yeah, right.
cuts out, and he's really upset, and he doesn't know what's going on. Well, he went under the bridge, and maybe it should be Red Hot Chili Peppers, and he lost his the signal. The signal was attenuated by that bridge, all the concrete and steel in there. Attenuated the signal, the RF signal, so much that it fell down below the noise floor, and we'll talk about noise, and his radio was unable to receive it anymore. So different building materials typical to the enterprise have different attenuation characteristics, or what we'll call here a barrier to propagation. So modern building materials, wood, glass, drywall, and plaster, they're not bad. RF signals can get through them pretty well. Heavier building materials, metal and concrete, and mirrors in some cases, attenuate the signals quite a bit. And again, that could be good or it could be bad. High attenuation means interference from other APs is less likely to make it through that wall. But it also means the coverage cell of a certain AP is going to be limited. So those are all important things to be aware of, especially when you're doing a design. So let's talk about what that looks like. So this is just a little drawing of a dual radio AP. It's got a 2.4 gigahertz radio, and that's the coverage area is the red circle for that. And it's got a 5 gigahertz radio, that's the blue circle. So you can see better coverage with the 2.4 gigahertz radio. More clients are serviced by that because it's got a higher coverage in this simple drawing. But we want to have 5 gigahertz coverage everywhere. And we'll talk about the reasons for that in a minute. And so to do that in an enterprise that's a little bit bigger than a single family home, for instance, or an apartment where single AP can give you coverage in both bands, we need multiple APs. And so in this case, we've added 2 more APs to increase the 5 gigahertz coverage. So now we've got 5 gigahertz coverage everywhere. And as people move through the physical environment, they move across cells, and their devices that they're carrying with them need to roam. That means establish a new connection to each AP as they move into a coverage cell. There's more roaming in 5 gigahertz because those cells are generally a bit smaller. And so effective roaming is a unique need for enterprises with multiple access points. So the next dimension to look at is the channels that each AP uses. So in the 2.4 gigahertz band, there's 3 channels we can use. Then we've got this AP on channel 1. Then we've got our 5 gigahertz radios, each on different channels. We've got one on 149, one on 64, and actually another on 149. So because there's enough distance between these APs, that might be okay because our coverage cells are kind of small, and so they're probably not transmitting at the same time, or their transmissions are not reaching each other, and we're not causing problems. So as we add users to a cell, however, now we got to think about the coverage from the transmissions of the users themselves. So the client-induced interference is something to consider. A client out here on channel 149, when he transmits, he might reach over here and cause interference. So that's important to know. The best thing to do is always to put your APs on their own channels so they're not interfering and the clients are not interfering as well. Okay, so a good analogy for spectrum and the available channels in a band is the highway, and to think of each channel as a lane on a highway. So I said there were 3 channels in the 2.4 gigahertz band. That's how it works in the US, 3 non-overlapping channels. And in the 5 gigahertz band, there are 25. So you could think about the 5 gigahertz band like a 25-lane highway. There's so much more capacity in a highway with that many more lanes. And that's really important to enterprises with multiple APs. So this is what that spectrum looks like. And on top here, we're showing the non-overlapping 2.4 gigahertz channels, 1, 6, and 11. There are 11 distinct channels in the 2.4 gigahertz band, but if we use the channels between 1 and 6 and between 6 and 11, they will interfere with the APs on adjacent channels. So we want to limit it to 1, 6, and 11 so we have the most non-overlapping channels we can use. The 5 gigahertz band doesn't have that problem when you're using 20 megahertz wide channels, which is the default. In that case, the channel numbers don't allow for overlap. And so you can see we've got 24 non-overlapping channels in the 5 gigahertz band, sometimes 25 depending on the regulatory domain. And you can see how many more available channels there are. So one of the unique things about the 5 gigahertz band, and you shouldn't do this in the 2.4 gigahertz band because of the spectrum limitation, but in the 5 gigahertz band, you can use wider channels. So you can switch on these 40 megahertz channels. That was a channel width that was introduced in the 802.11n amendment, and it's been available ever since. And if you use twice the spectrum, you get twice the throughput. A very simple way to make your Wi-Fi a lot faster. However, when you double the channel width, you cut in half the number of non-overlapping channels you have to work with. So we'd go from 24 non-overlapping channels to 12 non-overlapping channels with 40 megahertz wide channels. 802.11ac takes this concept quite a bit further with the introduction of 80 megahertz wide channels, like we see over here on the right, and 160 megahertz wide channels, because we're not even going to show you that because there really isn't enough spectrum to support that in an enterprise with multiple access points or neighbors that are also operating on the 5 gigahertz band. With 80 megahertz wide channels, we go down from the 12 available non-overlapping channels with 40 to 6. And so now we're having to design with only 6 non-overlapping channels. We need our APs to be pretty far apart for that to work without causing interference. And so it's uncommon to use 80 megahertz wide channels in an enterprise. Usually 20 or 40 are what's stuck to with the spectrum we have available today. So let's talk about noise and co-channel and adjacent channel interference. And sound is a great analogy to use for this. And actually it behaves very similarly, right? If we're just listening to music, it's us with our one radio. We've got no noise in the environment that our music is competing with, and everything's loud and clear. But when we turn on other radios and other people are listening to music, say you're in an apartment building with thin walls and a bunch of college kids are all, everybody wants to listen to music all the time. So your neighbor's got their music playing, you turn on your stereo, and you know what? Their music's kind of loud, so you need to turn yours up pretty loud. And now the other neighbor wants to listen to music, and it's hard for them to hear anything at all, so they turn up theirs up really loud. And eventually the whole building everyone's got their stereos cranked to the max, but nobody can actually hear their music. It's because of the noise and the interference, if you will, coming from all the neighbors. The way to fix that, the best thing you could do, is have everyone just turn their stereos way, way down, actually. And then they'd all be able to hear the music in their own apartment without getting interference, noise coming through the walls from the people around them. And so that difference between the signal you're receiving and the other signals that you don't want to receive, that's the signal to noise ratio. all those the noise we can think of as being the surrounding apartments, and the signal is your own stereo in your apartment. So noise for Wi-Fi is surrounding APs. Certainly APs operating on the same channel that you aren't connected to are considered noise. But also, remember, spectrum's unlicensed. Anyone can use it for just about anything. There are sources of non-Wi-Fi interference that show up as noise as well. The 2.4 gigahertz band especially is plagued with some of those things. So Bluetooth, microwaves, motion detectors, Zigbee, you name it, a lot of different things. Even USB 3 hubs sometimes can emit 2.4 gigahertz energy and raise the noise floor there in that band. So 5 gigahertz with so much more spectrum and less propagation because it attenuates faster, actually has a lot less noise in it. So we can achieve, in general, higher signal to noise ratios and have better performance in the 5 gigahertz band. So another way to think about this, and this is a really good visualization, the 2.4 gigahertz band is like a wide open, crowded and noisy sports bar. Everyone's kind of shouting across the table at each other, the TVs are blaring, the music's pumping, and you're just screaming at each other just to have a very simple conversation. It's hard to comprehend what people are saying, even though they're being so loud. And that's because there's so much noise outside of the conversation you're having. The 5 gigahertz band is like a really nice, elegant restaurant. You're there with your significant other, and you can talk in a very comfortable tone, and you comprehend each other just fine because it's so quiet there. The noise floor is so low that you don't have to speak very loudly to create a big difference between the signal of your voice and the noise, the surrounding noise in the environment. So co-channel interference, we briefly looked at what that means, and really what we're talking about is APs being on the same channel. So you can see channel changes going on here, and sometimes we've got APs on the same channels, and we're also watching these cell sizes change a lot. What we're seeing here is the effect of RRM, radio resource management, or sometimes it's called auto channel planning or auto RF. This is the algorithm that is built into enterprise WLANs that automatically sets the AP radio channel and the transmit power that it uses. And it's marketed as a very effective tool. It can save you a lot of time in doing a design because the APs can kind of we can take data from all the APs and what they can hear in the RF and generate our own channel plan and transmit and radio power plan. And on top of that, it's sort of self-healing. As time goes on and interference sources show up, we'll just change channels automatically when those are detected, and things will go great. Unfortunately, in practice, solving that problem is much more complex than what it sounds like. So the results from using RRM often in a high density network don't look too good. You could end up, it's hard to believe, but it happens. You could end up with 3 APs all on the same channel. And when they're all on the same channel, they're all contributing noise to each other, which affects that signal to noise ratio. And they're all, Wi-Fi is a very polite protocol. One of its characteristics is that it listens before it talks, LBT. And so what that means is a Wi-Fi phone or an AP or a laptop, anything that's speaking Wi-Fi is going to listen to the channel before it transmits, and if it's not empty, if it's not available, it'll wait. So if one of these APs is transmitting, the other ones will wait for it to stop before they start transmitting. And now we're all sharing what's called the same collision domain, and we're all limited to the airtime that's available in that particular channel. That's why if each of these APs is using a separate channel, they're all in their own collision domains, and we've got actually 3 times the capacity now than we would from a single channel. RRM can cause coverage issues too when it changes transmit power, especially in its default state where it's sort of unconstrained. And these things can sort of come and go intermittently, and it's hard to keep an eye on what's going on. So the tools we have, Sapphire Eye in particular, are really good at monitoring RRM and what it's doing. So you know, hey, this AP's channel changed, 25 times yesterday. That's very disruptive, by the way. Every time the channel changes, all the clients get dropped from that AP and they have to reassociate. So it's a great way to keep an eye on that if you're using it. So a little change of pace here. So this is a little thought experiment. So which one of these laptops would you buy? These are the specs that are usually published. These are actually real laptops that at one time at least were on the market. And it looks pretty obvious. If money was not a concern, you'd buy the laptop on the right. That one's got an i5 processor in it. It's faster than that i3, so you're going to have better performance, right? Who wouldn't want an i5 if they had that option? But down in the specs, you'll see really significant differences in the Wi-Fi capabilities of these 2 machines. The i3 on the left has an 802.11ac chipset, and that adapter supports the 5 gigahertz band that has all that extra capacity, that has greater throughput, that is less prone to interference, that will result in much better performance, especially in an enterprise. The laptop on the right has an adapter that only supports the 802.11b, G, and N standards. So that's kind of shorthand for saying this adapter does not support the 5 gigahertz band. It only operates in the 2.4 gigahertz band. And what did we learn about that earlier? There's only 3 non-overlapping channels. There's a lot of interference. That's the noisy sports bar that you don't want to do business in, especially in the enterprise. So even though the laptop on the left has a slower processor, anything that uses the network, which is any application you're using today, is going to have better performance thanks to that better adapter. So it's good to learn about the standards. I kind of threw out terms, 802.11g, B, N, and AC. But that's really important in learning about understanding the capabilities of the APs and clients that you've got in your environment. So Wi-Fi 6, big announcement yesterday from Apple. The new iPhone will support Wi-Fi 6. Wi-Fi 6 is the next major amendment to the 802.11 standard. It's 802.11ax, and the Wi-Fi Alliance is trying to simplify the marketing around these releases. And so we're just going to call this Wi-Fi 6. After the next big one will be Wi-Fi 7, and so on and so forth. Make it easier to know. Yeah, 6 is bigger than 5. I'd rather have 6. Easier to remember than, do I want 802.11ac or 802.11n or 802.11a? I don't, who knows? So the numbers are just for simplicity. But whereas with other standards or other amendments, we saw most of the focus on making Wi-Fi faster, 802.11ax or Wi-Fi 6 is actually a departure of that. It does result in faster speed, but it does that by making the use of the spectrum much more efficient to reduce congestion and operate and share spectrum in ways that are more similar to LTE in the way cellular phones share the spectrum that they have available. So it uses a form of channel multiplexing for better airtime sharing. And the feature, the headline feature of 802.11ax is going to be OFDMA. And that's a really interesting feature, quite a bit beyond our, Wi-Fi 101 fundamentals that we're talking about today. But if you do a Google search for 802.11ax and OFDMA, you'll see some really fascinating things about it. So very good, very cool technology that's catching on very quickly, and is interesting to see how that is developed. We should see that amendment ratified hopefully by the end of this year. And this is a handy way in a Windows box to figure out what are the capabilities of a machine. So if you go into PowerShell or the command line interface and just run this netshow wlan show interface command, we'll see some basic information about the adapter that's installed. And most crucially here, the description actually shows the name, the model name of that adapter, which you can take, pop it right into a Google search. More than likely, the first result will be the manufacturer's specs or support page for that adapter, which will tell you exactly what it is. So in this case, we're learning that it's a 2-stream 802.11ac adapter. So very handy and easy way to learn about your clients. So we've talked a lot about Wi-Fi, but to really address, we've been specific about Wi-Fi and the RF and contention and APs and everything that's happening in between the client radio and the AP radio. But for clients, or for end users, I should say, to really believe they're having a great Wi-Fi experience, it takes more than that. It takes great device capabilities. It takes a good internet connection if they're using applications on the internet. That needs to be fast too. The environment needs to be free of sources of non-Wi-Fi interference. And the network itself, upstream of the access points, needs to be sound as well. And the applications that are provided by that network needs to be speedy. There's a lot more to application performance than just Wi-Fi that gets all the attention. And with our tools, we can make it easy to identify which leg in this experience is the root cause of a problem. All right. Well, with that, Don, I think I'll end it there and send it back to you.
Thanks, Jim. Great work as always. Love your presentations.
My pleasure.
Yeah. So we did have some questions come through. Thanks for those. I'll get to those now. And some other folks catching up on telling me where they're from. We really appreciate it. Had some California folks and some other folks around the U.S. Pinging in here and letting me know where they are. And some other folks actually going to Wi-Fi Trek. So thanks, Jonathan. Yes, looking forward to seeing you in Nashville as well. Looking forward to the rest of you as well that are coming to our regional user group. Jim, you had mentioned about Wi-Fi 6 being supported by Apple devices. Is Mobileye ready for Wi-Fi 6 is the question.
Yeah, we are, Mobileye is entirely software based, and it's showing you what a device's capabilities are. So Mobileye will be ready for Wi-Fi 6 when it becomes a broader reality in the enterprise. we'll be right there with Wi-Fi 6 support. I think today we're focused on 802.11ac and previous generations of Wi-Fi there. But for us, it's not a matter of developing new hardware. It's just updating our software on the software side to support that. So we'll get there and it won't take very long.
Yeah, absolutely true. All right, question from Chris here. Can you explain what signal value means in detail?
Yeah. So
we may not have time for in detail, but
well, actually, there was a good talk at WLPC, I think 2 years ago, about what RSSI actually is or means. It's actually quite a rabbit hole, but the shortest explanation is RSSI is the value that we talk about most in Wi-Fi when we're talking about signal strength or signal value, and that's the received signal strength indicator from the device during the measurement, and it's measured in decibels. In Wi-Fi, our reference is milliwatts. So you'll see that as dBm, decibels, reference to milliwatts in Wi-Fi. And it's a negative number, usually somewhere, in the neg 40s down to the neg 90s is what we see.
All right, thank you. We've got time probably for one more question here. Some other folks mentioning where they're from. I got a shout out for North Carolina, Huntsville, Alabama. Huntsville, I believe, is close to Nashville, right? Is that driving distance? Maybe we'll see Jacob at Wi-Fi Trek too. Let's see here. What about 5G? When do you think this will be available? Now, I guess this is another one of those rabbit hole things. But maybe Jim, just some of your thoughts on when do you think 5G will it ever? I guess maybe the first question is, will it ever become mainstream? Do you think there's a world for it, compared to Wi-Fi? And, what do you think the timing's like for that?
Well, we're seeing the cellular carriers rolling out 5G in the United States, at least already today. Right now, it's limited to using the millimeter wave band, which I believe is in the 24 gigahertz spectrum. And like the difference in propagation between 2.4 and 5 gigahertz, the propagation for that millimeter wave band is very small or very short. It hardly penetrates anything at all, so you need a lot of radios for good coverage with millimeter wave band. However, that also supports much higher throughput, and that's how you see in commercials and bandwidth tests, cellular radios, 5G radios pushing over a gigabit of throughput over that 5G connection. So when will it be available? It's going to take some time to get penetration. I think millimeter wave will probably in the US be limited to urban areas where it makes sense to deploy those base stations very densely. And they'll also, to really get coverage in buildings, they'll have to have radios deployed in buildings as well. So it'll be an interesting, next couple of years as we see the carriers and enterprises negotiate how that's going to work to get 5G into buildings. So yeah, those are my thoughts about it. There's a lot of different opinions about it out there. I don't see Wi-Fi and 5G really being competitive. A lot of it has to do with the business models, right? Wi-Fi is unlicensed and anyone can build and deploy their own Wi-Fi network. And once it's done, it's essentially free. 5G is a cellular carrier technology, and their business model is to charge you a subscription and make money on the data that you use. And so you'd have a data cap, and it ends up being more expensive. Of course, they both have great use cases, and they're just the same way LTE complements Wi-Fi today. I think that trend will continue in the future.
Great. Thanks, Jim. Thanks for the question, Sean. Jim, I'm thinking we've got time for just one more. Is that okay with you?
Sure.
All right, cool. So this question is for Jim, from Jim, excuse me. Will the 7/6 signal system detect external based signal interference issues? For instance, there is a growing deployment of 5.8 gigahertz point-to-multipoint networks for delivering broadband services to end customers. Yeah. What are your thoughts on that?
Yeah. So we're talking about wireless ISPs or WISPs that use high-powered radios, sometimes Wi-Fi based, in the 5 gigahertz band that's unlicensed. And can we detect those with 7 signal systems? Yes, we can. So Sapphire Eye has a spectrum analyzer that runs continuously, and it saves that data to the cloud. So we save a month's worth of history from every Sapphire Eye. So it's very easy to go back and look at spectrum over that period of time and see what non-Wi-Fi interferers are there in the spectrum that you're sharing it with. And if it is a WISP or a radio that's using Wi-Fi, we can give you a lot of intelligence about it and what it's doing as well. So, yep, definitely capable of helping you out with that.
All right, thank you. A couple other folks, Florida here. Jim, why not one more? What do you say?
Sure.
I got a question for Felipe. This may be a quick question. Any ETA on the release of Windows 10 updated package for Windows 10 Mobileye?
We support Windows 10 today, so
Yes.
You should be good to go with that. Yep.
I figured that would be a quick one. That's why I dropped it in there.
One.
Awesome. And so from Florida, but watching in the Philadelphia airport. Oh, good luck. That's, I think, one of the most congested. Speaking of congestion, one of the most congested airports in the country, if I'm not mistaken. And that's where I grew up. Folks, thank you very much for joining us today. Great job, Jim. Thank you. Have a wonderful rest of the week, everyone, and hope to see you all in Nashville next week.
All right, great. Thanks, everybody, for showing up today.